Okay, time for some definitions. End diastolic volume, end systolic volume, and stroke volume. The end diastolic volume is the volume in the blood in the ventricles at the end of diastole. And systolic volume is the amount of volume of the blood in the ventricle at the end of systole, or after the ejection of blood out of the ventricle. Stroke volume is the amount of blood ejected by the heart in a cardiac cycle or a heartbeat, and it is the difference between end diastolic volume and end systolic volume. For example, if the volume in the heart at the end of the diastole is 120 milliliters, and the volume in the heart at the end of systole is 50 milliliters, your stroke volume will be 70 milliliters. Heart rate, that's the number of beats per minute. First important equation here is cardiac output, and this is stroke volume times heart rate. If stroke volume is 70 milliliters and heart rate is 70 beats per minute, your cardiac output is approximately 4,900 milliliters, or 5 liters. Total peripheral resistance is the resistance offered to the flow of blood by all the vessels in the body. This cannot be measured. So we have the second important equation is cardiac output times the total peripheral resistance is the mean arterial blood pressure. Now, since we cannot measure total peripheral resistance, this brings us to Poiseulle's law. It was designed by a French physiologist looking at a single vessel. It states that flow, or Q, equals the change in pressure divided by resistance. He found that resistance is represented by this equation. 8 nu times the length of the vessel divided by pi r to the 4th power. 8 always remains the same. So take a deep breath in. This is all numbers. You will be relieved at the end of this. 8 is a number that doesn't change. Nu is the viscosity of the blood. That doesn't change. L is the length of the vessel. That doesn't change. Radius is the only factor that does change. That is the radius, represented by is pi. So the only thing that can change is the radius. The rest are constants. If you change a vessel's radius or diameter by a factor of 2, either cutting it in half or multiplying it by 2, what will happen to the flow? Since this is a radius cubed,